In this video, we'll see how modules works in Haskell, and in order to do so, I do have here an empty folder, and here we'll initialize a new project, which for now only contains an executable with no library. Now, if we go into the main.hs, we'll see that we have some strange suggestion, which is not really what we expect to have here, and that is due to how the naming convention for modules works in Haskell. And in particular, we'll see that it has to respect the project structure, but we'll get into the naming convention in a moment. For now, we are just interested in removing this suggestion. In order to do so, we just have to open a VS Code instance in the folder of the project, which is the one with the .cabal file. And we see that when we do so, we no more get any suggestion, since now the module respects the project structure. But once again, we'll see this in a moment. First, let's see how we can create a module and export the code inside it. So in order to do so, I'm going to create a new folder that I'll call lib, and this folder actually has to be into the root directory. And here we are going to define our module. For this example, we are not really interested in the content of the module, so we'll use the complex definition that we created some exercises ago. So here I have copied and pasted the complex definition from the data type exercise video. And well, the purpose of modules, as you may know, is to reuse code without having to copy and pasting it where we need it. And we can create a module by using the module, and after the module keyword, we have to specify the name, which has to be the same of the file we are in, without, of course, the extension. So the name of this module has to be complex, and also by convention, the first letter of the module name has to be a capital letter. And then, in order to have some proper Haskell code, we have to open a block of declaration, and we can do that by using the where keyword. And with that, this is the most simple way to define a module in Haskell. In fact, this is a proper module, and what it's doing is taking everything that is defined here and exporting it all. Now, this is sometimes a behavior that we may want to avoid, and we can do that by using some parentheses in which we can specify just the name of the functions that we want to export. In fact, say I just want to export real, imaginary, and the imaginary unit. I can do that just by typing here the things that I want to export, in this case these three functions. And now complex from tuple is private to the module, since we are not exporting it. But as written here, also the data type complex is private to the module, and in order to export the data type too, we just have to include it into the list, and this is fine. We are exporting the data type, but not anything else. In any case, this is our module. We are exporting a type and some functions, and well, just remember that with the types we are exporting also the instances. So maybe we should try this module, and to do so, we'll go into our app, which contains our executable, and we can import a module we define or we know exists by using the import keyword and then specifying the name of the module, which remember in our case is just complex. So here I'm writing import complex, and theoretically this should be a valid import statement. This is the simple import statement that we can have, but we see we have an error, and this is because we can't find any module that is called complex. And we also see that the reason for that is that complex is not a module in the current program or in any known package. And well, as we know, the current program is defined into the .cabal file, and in fact here we do not have anything that specifies where to find the complex, but we know how to fix this. We just add a library section, which remember takes the name of the library by the root directory, in this case modules, and here we have just to specify some fields. Now the library depends from the base library of Haskell, and the source directory of the library is the lib dir, which we created before, and the default language is still Haskell. Alright, this is fine, but remember that we have to specify what modules are exposed from a library. So we'll write here just exposed modules, and there follows a list of modules name that we are exposing. Let's see if the main is happy and still is not happy. Well, because you have to remember that we should also depend from our own library, which is the modules library in this case. And now we see that we can find a module that is called complex, and we see that all the programs works fine except for the construction of a complex. And if we hover for more information about this error, we see that we do not have any constructor which is called complex, even if in our complex module we exported the complex type. And actually the error is right here. We exported only the type but not the constructors, and so these RE, the IAM, and the complex constructors are private to the module. So how do we export those constructors? Well, we just have to include them into the list, but not as simple functions. Instead, we have to open another list of things to export right next to the data type of which the constructor we want to export. And in this case, we want just to export the complex. So the RE and the IAM constructors are private, but in the case we were to do something like this, where we want to export all the constructors of a given data type, Haskell provides us with a shortcut for that, which is just to use two dots. And this is exporting all the constructors, as we can see also from the main. Now our simple import statement is working properly, and now we have a definition for our complex. And if you don't trust me, we can compile and run this executable into our project by just running cabal run into the root directory. And we see that we got our input the real part and created successfully our complex number. And so far so good, but let's see how we can improve our import statement. In fact, we are already having a suggestion from the Haskell extension, which suggests us to use some parentheses and then complex and then or parentheses and then complex. So what is going on here? Well, these parentheses are just the same thing of the export list into a module declaration, with the difference that this is an import list, but it acts the same way. Here we specify the things that we want to import. So say we have our own real function here, which is doing something totally different from the real of our module. Well, we still, of course, want to export in general our real function from the complex module, but we don't want it into this module because we do already have our own. And if we only imported the module like this, then using real gives us an ambiguous occurrence of real, and this is because we do have this definition of real and also this one imported. So one way to fix this would be either to use the import list to specify exactly what we want to import, or maybe we want just to hide something between the things that we are importing from this module, and we can do that by using the keyword hiding and then another list with things that we do not want to import, in this case the real function. And we see that now real is clear what it is doing. Another way to make clear from where we want to access some function is to qualify the functions that we are importing from a module, and this means that we have to add a keyword between the import and the module name, which is qualified, and this complex that previously was working now is not recognized. And we also get a suggestion that perhaps we meant to use complex.complex imported from complex. In fact, this qualified here is forcing us to specify the module we are using in order to use something that we imported, and this way there is no problem in recognizing what this real is. It is our function definition, because if we were to use the complex real, we had to write something like complex.real. And now the error is only because we expect some IO here, but we can work around this by just storing this partial result. And we see that this real is not ambiguous since we are accessing it through the complex module. And by using this qualified here, sometimes the module's name can be some very long name. And so Haskell provides us with another keyword that is the as, which has always to follow the module name. And this is just giving an alias that is working for this particular file to access that specific module. In this case, we can just use a short version of complex, and now we see that complex itself is nothing that we know, but we can just access that same module by using our alias. Alright, and just to make it clear, you can still use, and you should, the import list while using your import qualified, and this is just a nice way to keep track of what we are importing from where. And with that, we saw how to properly export things from a module and how to import them into other Haskell files. But I promised you that I would have explained why when we access the main.hs, which is working fine here, into our main Plutus oriented Haskell folder, we get some strange suggestions. Also, the imports are not working, and this is because of the naming convention. So let's dive into the naming convention, and in order to do so, I'm creating here a new folder that I'll call as the module of complex, and here I want a file that I'll call utils.hs. And we see that in this file, the suggestion we have is to call the module as complex, which is the name of the folder, dot utils, which is the name of the file. And we know that this is a valid module declaration, and this suggestion was given because, as we said, the module name has to reflect the project structure, and this is a convention that is built into Haskell, and that is why in the Plutus oriented Haskell we get this suggestion, which is suggesting us to call this module code, then executable, then modules, then app, and then at the end main, because it is expected to this module to be reflecting the project structure. So back to our complex utils. Now we understand why we have to call this module like that, and well, we can just move things like complex from tuple into there. Of course, we have to import our complex here in order to have the complex type definition. And when you add a new module, remember always to add it into the exposed modules if it is intended to be used outside the library in which it is defined, or to use the other modules field if it is intended to not be visible outside. And in order to specify this specific module, remember that the name is this whole name, so it is complex.utils. So we have to specify this here, and well, actually I want it to be visible, so I'm adding it by using a command to the exposed modules. And now we can use also complex utils inside our main executable, and we see that we can now use the complex from tuple exported from the complex.utils module without problem, and the executable works just fine. So in this video we saw how to properly create modules and export functions and data types with constructors from the modules. We saw how to import properly things that we need in other files. We also saw how to reflect those changes in the .cabal file, and we understood why we got that strange error when we open the same file inside another directory, which is due to the naming convention. So with this, we covered modules. I hope you had the occasion to learn something from this video. If that was the case, consider to subscribe to the channel. In any case, I want to thank you for your time. Remember to stay decentralized, and I will see you in another video. Bye bye.